Alright, so let's do some problems with inverse trig functions. I'll do some examples for you. Let's start with problem number 2 on the worksheet. So on the worksheet, problem number 2, this is a Tuesday worksheet. It says cosine inverse of 0. What they're asking you is, where is cosine 0? Okay, so cosine is 0 on the unit circle here. That's where cosine is 0. So if cosine is 0 there, that means that has to be at pi over 2. And that's done. Alright, let's go to number 6. Let's say tan inverse of -1. Okay, this is tan inverse. Tan inverse on the unit circle only exists here and here, the first quadrant and the fourth quadrant. Okay, since it's a -1, it has to exist in the fourth quadrant because it's positive here in the first quadrant, tan inverse, and tan inverse is negative here on this one. So if it's negative, it's got to be 45 degrees. You could say you can't go around this way, okay, so you can't do that, so you have to go in this direction, okay, negative 45 degrees. But we don't like degrees, so we're going to do it in terms of radians, negative pi over 4. And that's where tan inverse equal to negative tan inverse is. So the angle that gives us -1 for a tangent is negative pi over 4. So negative pi over 4. That's done. Okay, let's take a look at number 13. These are all fairly easy. So we're talking about secant inverse is equal to 2. So when does secant turn into 2? If you remember, secant is related to cosine. It's 1 over cosine. Okay, that means that this must have been 1/2 for this to turn into 2. So we have to find out where cosine is equal to 1/2. It's a positive 1/2. So that means it's got to be in the first quadrant. It's got to be 1/2 right here. So what is that angle right up there? Well, that's either 60 degrees, but we don't like degrees, so we're going to go pi over 3 in terms of radians. So that's pi over 3. Okay, so let's move on to problem number 20 in the second part of this. So problem number 20, they give us a cosine of arc cosine of 1/2. What they're telling it is, what they're telling us is this: somewhere cosine is equal to 1/2. But we just found out where is cosine 1/2 at pi over 3. So just the last problem that gave us pi over 3. Okay, so this now turns into pi over 3. Now we got to take cosine of that, which turns into 1/2. Okay, so if you notice, these two, arc cosine and cosine, undo each other. Okay, the reason it turned out to be the same is because arc cosine exists in the first quadrant, okay, and cosine is 1/2 also in the first quadrant. So they match up. Both of these are in the first quadrant, so therefore they just undo each other. But not always. Okay, let's take a look at 22, which is a little different. Okay, let's say we have a arc sine of 5 pi over 6. So let's go find this first. What is sine of 5 pi 6? On the unit circle, 5 pi 6 is located right there. Okay, so that's 5 pi over 6. Well, what is sine right there? That's going to be positive 1/2. Okay, so here's the problem. I have an arc sine, which means same thing as sine inverse, of 1/2. But sine inverse does not exist in this quadrant. Sine inverse exists only in this one and this one. Since that's positive, since 1/2 is positive, so we have to find where it's positive. So it's sine inverse is positive there. So we're going to go to, maybe I should draw a triangle that's very similar to this. So I should go over here, okay, and that's going to be pi over 6. So that's 1/2 right there. So I have to use that. So I have to use pi 6th. So pi 6th. So notice They didn't undo each other here because this is located in the second quadrant. If this was located in the first quadrant or fourth quadrant, they would undo each other. Okay, a couple more problems, then we're done. We'll keep working on this today in class. So number 28. Okay, so we have a sine of arc tangent of 5 over 12. Alright, arctangent exists in the first and the fourth, so I have to draw a triangle because 5/12 is not part of the unit circle. But this is positive, so that means it exists over here, so I'm going to draw a right triangle. Okay, I'll call that angle X. So they're telling me these are the sides of a right triangle. So this is the opposite and this is the adjacent, because that's what tangent is. So I'll put 5 here and 12 there. Well, I have to go find out what the hypotenuse is, so I'm going to use the Pythagorean Theorem. 5 squared plus 12 squared is equal to c squared. That's 25 plus 144 is equal to c squared, and that's 169 is equal to c squared. So c is equal to plus or minus rad 169, which is c is equal to plus or minus 13. Hypotenuse is always positive, so that's going to be 13. Okay, now I can answer the question. This means that triangle right there. So I have to make out the triangle, then I can answer the question, what is sine? Well, sine of x turns out to be opposite over hypotenuse, so my answer is 5 over 13. Now if they ask me what is cosine of arctangent of 5 over 12, then I'd go, that is adjacent, which is 12 over 13. Okay? Alright. So one more, and that will be the end of the lesson. So let's do problem number 29. Okay, so cosine of arc sine of negative 8 over 17. Okay, arc sine exists in the first and the fourth quadrant, but this is negative. Since that is negative, so it has to exist here in the fourth quadrant, so I'm going to draw my triangle there, because 8 over 17 is not part of the unit circle. There's my right triangle, and that's my angle there, x. Okay, so this is the opposite, so which is negative 8, and this is the hypotenuse, which is 17. Okay, so opposite over hypotenuse. Now I got to find out what my side here is, so I'm going to use Pythagorean Theorem. Let's go 8 squared plus b squared is equal to 17 squared. Okay, this is 64 plus b squared is equal to 289. 17 squared is 289, so b squared is equal to 225, hence my b is equal to plus or minus 15, or plus or minus rad 225, plus or minus square root rad 225, that is. So this is positive, so therefore that's going to be positive 15. Okay, so now what is cosine of that? Cosine is adjacent, which is 15 over hypotenuse, which is 17, and that's the final answer. Alright, that should be it. So let's print out the worksheet.